That's advanced emergency braking, which is a driver assistance system that doesn't suck. AEB is not just another ADAS system that annoys you and beeps at you whenever there's a car in front of you trying to turn off the road. It is a system that genuinely improves the safety of modern vehicles. The intention of the system is to prevent or mitigate the severity of a crash in the event that the driver does not respond or do anything about the obstacle that's in front of them. Presumably they're going to be on their phone or they're trying to change the climate settings on their A3 tablet mounted to the dash. We're out here talking about ADR98, and this is the Australian design rule that stipulates the performance requirements for this system. In the ADR, there's a whole bunch of technical requirements, but in there is also the test requirements, which is what we're out here doing today. The majority of the test requirements are split into two main parts. There's the vehicle-to-vehicle part and the vehicle-to-pedestrian part. In the vehicle-to-vehicle part, we have a vehicle under test, which is this one here, and it drives directly behind a target vehicle. Now, that target vehicle could be an actual car or it could be a foam target. The test vehicle drives at speeds ranging from 20 to 60 kilometers an hour, and the target is either stationary or moving at 20 kilometers an hour. There's 20 tests in total in the vehicle-to-vehicle part. At lower closing speeds, you're not allowed to hit the target, but at higher closing speeds, say when there's a stationary target and the vehicle doing 60 k's an hour, you're allowed to hit it at around about 45 k's an hour. And it really depends on the load condition, because the vehicle's got to be tested in multiple load conditions as well. For the vehicle-to-pedestrian part, which is what we're out here testing today, the vehicle again travels between speeds between 20 and 60 kilometers an hour. And our little friend here walks out in front of it. He does 5 kilometers an hour nominally. The target is an ISO compliant 6-year-old target, or it's indicative of a 6-year-old. Unlike the car-to-car test where you're allowed to use an actual car, we're not allowed to use an actual child. We have to stick with a dummy on this one, which says a lot about 6-year-old kids' decision-making abilities. What makes it so difficult though on this new part of this testing with the mandatory dates that are coming into force in Australia this year is that the precision that's required is really, really high. So the test target has to travel at 4.8 to 5.2 kilometers an hour. So it's got a very narrow window of plus or minus 0.2 kilometers an hour. He has to travel completely perpendicular to the direction the vehicle's traveling at. The vehicle has to travel within 2 kilometers an hour. The vehicle has to stay in a dead straight line within 0.2 of a meter or 200 mil. And what's most important is all of this has to be timed up so that when the vehicle is driving down the road or down the test facility here, that the projected collision point between the pedestrian and the car is exactly in the center, plus or minus 100 millimeters. That's less than 1/10 of a second in terms of the timing and sequencing of the whole thing. So there's a lot of science behind it, and it's a massive effort by the AIC team over the last year to be able to get this working. So how do we get this to work? Well, we have a robot platform here. It does have suspension because it needs to get driven over. It needs to drive itself. It has high accuracy GPS built into it, as does the vehicle. And they're coordinated via a radio modem system and also a base station which gathers dozens of satellites. We need that because you have to have an accuracy below 2 centimeters of each of these vehicles, and regular GPS can't do that. So all of the scripting and coding that's been custom written by the AIC team is measured and controlled to make sure we're compliant with the ADR using all of those systems. It's a massive coup for the AIC team that this has been designed and developed and programmed in-house, and it's functional. And it's a test that we're proud to offer the industry in the OEM and the aftermarket space. So if you have any projects, be it an OEM, an SSM, or an R&D project, give us a call and we can absolutely help you out with ADR9801 testing.